Okay, so we've just looked at the incredible work of today's students. It's now time to take a glimpse of the kind of extraordinary things they could be doing post-graduation as we look at the evolution of industry. So first, to start off, we're going to be looking at the changes being made to the UK's power grid. And so, ladies and gents, I'm really excited to invite to stage to tell us all about it. Well, returning to stage is John McLaughlin, but also he'll be joined by Peter Hay and Danson Joseph from the National Grid. So, ladies and gentlemen, please give them a warm welcome. Thank you.
Okay, so Rich mentioned there the grid, and I want to expand on that. We've got engineers all around the world who are currently designing and installing the next generation of the grid. One that's flexible enough to take on all types of renewable energy, as well as reliable enough to meet the demands of today and tomorrow. So let's see how we're doing this in the UK. I've got National Grid with me here today, so why don't you go ahead and explain to me a little bit more about what you do.
Right, thank you very much for having us here. Most of you might know us as the company you call when you smell gas, but that's not the part of the company that we're from. Fewer people know that National Grid is actually at the heart of the electricity industry in the UK. In England and Wales, we own and operate about 10,000 kilometers of overhead transmission lines and cables, connecting about 330 substations together all the way across England and Wales. We have a second role, though, and that's as the system operator, where we balance the demand for electricity with the supply for electricity on a second-by-second basis. And in this sort of environment, our vision is basically to connect consumers to their energy sources today, but also to be the trusted partner to connect consumers to their future energy sources.
That's great. So I understand that there's over 7 gigawatts of onshore and about 4 gigawatts of offshore wind energy in the UK. Yeah. Up on about 20% of last year. So what kind of challenges does that pose for yourself?
Well, the UK has some demanding targets to meet from a renewable energy perspective, especially by 2020. And onshore and offshore wind are great forms of renewable energy, but they do pose some significant challenges for us. When we combine that with the high voltage cabling that we're using more and more, especially in cities like London, our interconnections through to Europe to try and make sure we work on a European grid scale, and the decommissioning of our nuclear and fossil fuel plants, things like wind farms, which are based on power electronics, end up creating power quality artifacts, which start interacting with our other customers. And as system operator, our mandate really is to control and manage that interaction. And we can't manage that if we can't measure it, so we knew we needed better data.
So did you experience any limitations with older instrumentation?
We've been through quite a few different types of instruments, most of them off the shelf. We evaluated a few contemporary options based on off-the-shelf components. And the biggest problem we had is that they couldn't integrate into our information systems, the analytics we wanted to put onto it. We weren't able to gather all that information from substations across the country. The second part, of course, is some of the hardware is just not capable of measuring what we needed it to measure. For example, the wind farms we were talking about and the high voltage DC connections, the modern generation, emit very high frequencies onto our grid. Existing equipment is built to a standard that doesn't really cater for that and just couldn't measure the bandwidth that we needed.
And so we assembled an expert team. Actually, it was Danson mostly, a little bit of help from James McNally. Anyway, our expert team set about designing and building the system that we needed to address some of the shortcomings of the traditional instrumentation. We recognized that we needed our system to be flexible, and that's flexibility to deliver what we need it to do for us now, but also to anticipate what we might need in 5 years and leave us the scope to increase what it can deliver to meet those needs too. We also needed to bring access for our data. We were keen not to be data focused though. A lot of talk about big data, and that is great. Our system gives us access to vast amounts of data, but it goes a bit further in that what's actually useful to us is disseminated information. So we needed our system to extract what's useful information to us and make that available to us within a few clicks. So you can see here roughly it's our system. If you imagine in the substations around England and Wales, we've got hundreds of instrumentation transformers. That's current and voltage transformers. And we use them to detect the quality of the electricity supply. That's the quality of the electricity that we rely on day in, day out. On this diagram, you can see the transformer's signals feed into our monitoring system, where it's converted to a TDMS file format. We then can pass the TDMS files through our rugged industrial network, where they're stored on a database. The final, most important stage for us is extracting useful information to inform our decisions from the data stored on that database. And so we committed to developing 110 permanent units, and they're going out to racks on our substations at the moment, and also 25 portable units, these funky little yellow boxes here. A few of the features, they've got a rugged enclosure to protect them from the environment. They've got a touch panel display so that we can configure them both on site and remotely, and voltage and current connections to read in from the transducers on our sites. They've also got network connectivity too.
Well, you've managed to turn a lot of data there into information, but how are you going to use that to then impact your own business?
Well, we use these monitoring systems to ensure the grid code harmonic compliance amongst other compliance aspects of our network. For example, if a wind farm wants to connect to us, we have to make sure that its impact won't be too deleterious for other users. We do that by a mixture of simulation of what the impact will be and measurement of what the impact will be. An example of this can be seen here. This location is from the south coast, where we have an interconnect connecting our transmission system with that of continental Europe. So it's a particularly important site. Here we can see harmonic distortion measured with our previous instrumentation. And here it is with our new compact Rio-based system. See, we knew that there was more going on, and we knew that we had to find a way of measuring it in order to manage it. That's where compact Rio has given us a great deal of value.
It's really impressive, guys. Thanks, Peter. Thanks, Danson.
Thank you very
Thank
much.
you.